What are we into today? Looks like a special treat here. Mesa Engineering. This is a Mesa Boogie. What is it? Oh yeah. What is that? The California Tweed Mesa Boogie. Pretty good looking amps, and from what I've read and seen and heard on the internet, they sound fantastic too. Very, very Fendery. This is the 6V6 440. Customer complaining it doesn't power up. Evidently he had a new power feed pulled to his house and they wired it double voltage instead of 120. So as soon as they turned the breaker on, it fried a bunch of his appliances and unfortunately this amp. So he took it into a guitar shop and they said, we're gonna have to send it in to Boogie because they were scared a transformer would be fried. Please don't be a fried transformer. Well, so this test setup I got here, that's a 0 to 120 volt Variac, a big rheostat in it, and I've got a current monitor on the back. That is my current limiting light bulb, 250 watt light bulb. So the Variac's plugged into the wall, the light bulb is plugged into the Variac, and the amp is plugged in series to the light bulb. So what I'm going to do is make sure this is on. I'm going to come around here and watch the current while I turn the voltage up. And what I'm doing is watching the amps on the back here, the volts. It's got the power meter, the light bulb, and the amp itself, doing the sniff test. The amp is turned off. I just want to make sure we don't have any dead shorts, right out of the gate. Speaker's plugged in. Amp should be like it would be new. So how far are we up here? Going blind. We're 20 volts, no current draw yet. 50, no light bulb. We're not drawing any current. So the amp is totally dead. That's the full beans. So let's turn the heaters on. Turn the amp on, but leave it in standby. 30, nothing. Totally dead. That's telling me either the fuse is gone or the input transformer's gone. I'm gonna check the standby just for shits and giggles, even though I know it's not gonna work. Yeah, it's not gonna work. But I'll show you what I'm looking at over here. 100 volts right there. I don't know if you can see this, like a knucklehead. I put the display back here instead of on the front because I didn't have room. This Variac's from like 1960, but I'm not gonna buy a new one if this one works. So let's kill the power and pull the chassis and see what's going on. I like how this panel hangs in here, how the amp sits in, because all the knobs are, behind the front face of the amp, so I can lay the amp down face first, not damaging the knobs, and take the back plate off. I'm unplugged, obviously. Oh, and I set the clutch pretty low on the drill so I don't round over any screw heads or split any wood. That's the back trim plate. This is pretty clever. I don't know if you can see this. Check out the tube guard. I don't know if I like this or not. It's got these little plastic clips here to take the tube guard off. How easy is that to remove? Oh yes, I like that. I don't know, they're plastic, how long they'll last, but man, that's easy to remove. Metal, nice anti-vibration rubber. And it looks like there's only these 4 top screws. Now these I don't want to bugger these up, so I do them by hand. Nice and long. That's what she said. Yeah, don't tell those stupid jokes. Disconnect the reverb first. Remember, white is in the back, black is in the front on the reverb cable. White is in the back, black is in the front. Be careful not to break any tubes, and don't touch any capacitors, whatever you do. All right, let me get reset up before we dive into this. Well, the initial inspection, not so good. Here's a good overhead shot of the amp. I can't believe how clean this is for a Mesa Boogie. This looks like a clean, simple, nice design. It's not their typical pack as much shit on as many double-decker boards as you can get into an amp. But yeah, I don't know if you can see this. I've already discharged all the caps. They weren't charged up actually, but you can see the arcing here. You can see this device. It's went kaboom. There's the front side face of it. Hopefully I can still read the lettering, see what size this is. And the shielding, I have a picture of it. There's a big kaboom mark in there too. And yeah, let's look at the fuse. Focus in. Is that any better? No. Looks like the fuse is good. This fuse is not good, even though the big wire is all the way across. Can you see the flash? Yep, the fuse is toast. So we got carbon buildup here. That's exploded and the fuse is dead. Let's try to take some transformer impedance measurements. If we can figure out how this damn thing's wired. Because, you know, Mesa Boogie never publishes their schematics. Well, the first measurement I'm going to take is from hot to neutral on the plug. It seems to be okay. Well, dead short. Dead short where the 120 hits the board. Yep, 1 ohm. Shit. Alright, we'll pull the power connector. That's where the, let me see, 120 comes to the switch, out to the, and straight to the board. This is on the board. That's not good. So the transformer's unwired. Oh, that's not bad. Yep. 22 ohms. 22 ohms, what do we got? Going into the transformer. Oh shit. 1 ohm on the input to the transformer. Alright, I'm gonna get on the interweb and see if I can find what size power transformer this is. I would expect to see, you know, somewhere less than 10 ohms on the input side, but 1 ohm. Let's see if my resolution gets any better. 0.3. Oh, there we go. 2.1 ohms. That's better. 2.1 ohms. Transformer may have lived. Dead short. Well, that MOV is probably dead shorted. So I'm going to take that out of the circuit and see if I can figure out how the power supply is wired. I'll be back. So what I'm going to do is take this blown up metal oxide varistor out. I'm going to try to do it without taking the whole board out and without melting any wires. So hopefully they didn't bend the pins over underneath the socket board, underneath the circuit board. So if you tin the tip a little, solder that connection. Get it hot. Well, with a lot of finagling, I did get it out, and it's what it is. It's an MOV out of this lug and this lug. This took me a while to get out because I didn't want to goober up the traces. But yeah, that's the MOV. It's kablooey. It went kaboom. So here's the other part. Let's see if we can identify what size it is. I know the camera ain't gonna be able to see this. So I'm gonna Googleate this and see if I can identify what size it is. But first, let's confirm. That thing is wired straight across the AC. Can you see this? Yeah. Let's see if it's conductive. It should not be. MOVs are metal oxide varistors. The impedance should be, somebody loves me, the impedance should be very high until the voltage gets high, and then they dead short to blow the fuse. It works just like a power strip in your house. Yep, look at that. 22 ohms, that's a dead short. Shit, do I have any of those? And what size is that thing? 2.4 something. Well, I'm gonna Google, see if I can find something that'll work. Well, luckily here, I've been doing some continuity checks, and all the wires good and all the connectors are good. So while this arced and blew up, I think this brown discoloration is from the arc flash that came out of the MOV. But just to be sure, I'm cleaning it with alcohol wipe with, you know, isopropyl alcohol and a toothbrush. Make sure all the connectors are clean and dry. And then I'm gonna go take an MOV out of a Furman power supply I have and install it. What the hell size this is? If anybody knows how to get, I know Mesa Boogie's really tight with their schematics. They won't give it to anyone but service techs. And they must have some sort of airtight disclosure agreement with their service techs, because I cannot find schematics on this amp. And while I don't think it's too complicated of an amp, you know, it's probably very close to a black face or a tweed. It does have that power scaling on it. The 2, 10, 20, 30, 40, which they're probably, what is 6L6s? Is that what? Yes. No, 6V6s, my favorite tube. Yeah, they're probably just changing the, would they be changing the grid bias? Just making the bias voltage higher and higher and higher to get less wattage out of the amp? I don't know. It'd be curious. I'm curious to see how they do their power scaling, because these amps I think sound pretty good. Anyway, let me go get some parts, put them back in. I'll be back. Okay, with much finagling, I've got a replacement MOV soldered in. So I'm going to check to make sure is neutral is made, hot is made, and no more shorts between the two. Yep, that's good. Are we good? I think we're good. All right, let's put it back together and fire it up. Here comes the moment of truth. Both power switches are off. Hit the juice to the variac. That's on. Yep, no current draw. So let's turn the heaters on. Now we're getting a little current draw. 1300 milliamps, 14. Oh yeah, I think we got her. Is the light bulb glowing? 0.2 amps at 60 volts. I heard something. Well, relay is popping because we're getting enough voltage. We got a 1/4 amp. There goes the other relay. No light bulb. 0.29, all the way up. Are the heaters going? Yeah, let's let it warm up a little bit. Yep, there's the glow. Power tubes are heating up. Here's the moment of truth. High voltage. Yep, I think we got her licked. Yep, I can hear the noise. All right, I'll be back. Let's go get a guitar, see if we got her licked. Awesome. Yep. Wow. A lot of bass. Mids are all right. Yep, we got her fixed. All right, I'm gonna bolt her back together, put it in the amp, get it on full, well, first I'm gonna put it on full line voltage and see if I can check the plate voltage. How hot is this amp running? Let's see here. I'll be back. Well, I'm powered up on house power now, so it's about 117 volts here. Let's check the heaters first. 2 and 7. We want 6.3 volts. Never put two hands in an amp like I'm doing now, but that was a clear path. 6.35 volts, that's awesome. 6.3 spec, 6.5, I'm not going to complain about that. So 1, 2, 3. 3 is the plate. Here's the high voltage, 1, 2, 3. We've got, oh, DC, 425 plate volts, 4, 1, 2, 3, 4, 419, so 425 plate, the middle electrode is 418, and then the grid 1, 2, 3, 4, 5, yes, minus 41 volts. So this is a grid biased amp, and this one's running at minus 41 volts. Yep, so all the voltages look good. Of course I wouldn't know because I don't have the schematic. Yeah, it's fixed. Let's bolt it back together. So we're going to go across the plate here. 1, 2, 3, 425 volts, and I'm going to kill the high power. That's 230, 180, 160, 130, 90, 70, 50 volts DC can still kill you. We're down to 40, down to 30, down to 20. Yeah, now we're getting in the safe zone. 17 volts, 15 volts. So obviously the capacitors in here aren't that big, and there are some drain resistors. I don't know because I can't find the schematic. If I'm trying to hint, if anyone has the schematic, hit me up because I think I love this amp. All right, let's see here. Yep. It's Fennery's hell. I like it. Sounds good.